here at Liquavista at the Texas Instruments booth.
Yeah.
You are part of Texas Instruments, or partner?
No, we're an independent company, Liquavista. We're just partnering with Texas Instruments on new mobile platforms. Texas Instruments are providing roadmap support for e-reader type applications, smart mobile applications, and we're showing our new display technology in collaboration with their efforts around OMAP.
So this one right here, this is a mock-up of a design that could be?
Yeah, this is a mock-up of a real display. So the rendering on this mock-up has been done in a display manufacturing process. So it's a real display manufacturing process, but it uses design rules that are available in a commercial LCD fab.
So this is a reflective mode, totally.
These particular mock-ups are entirely reflective, but this technology is a new type of optical shutter. So you can use it in transmissive mode or reflective mode, or a combination of the two. And that's what we show here. We show that we've got a highly reflective mode in the display here, but we also have a mode where we can then go to colours and show deep saturated colours at the same time. The point being that you can show TV type display quality, but when you go outside into bright sunlight, you never lose the image. You may lose the colour, but you never lose the image. It's a really unique feature of the technology. The technology has been developed as a very close facsimile to LCD technology. So it's made in LCD factories, and it operates like an LCD, but it's X times more efficient than an LCD.
So it's when there's a backlight, it's basically like an LCD.
Yes, exactly.
Right.
But when there's no backlights, it performs just like color would. Just like magazine color would, it's stacking colors on top of each other.
So how soon is this going to be on the market?
We're planning to have this on the market by the end of this year. So first manufacturing capacities will be coming online at the end of 2010. We plan to see products retailing with our technology in by the middle of 2011.
So why is this the mock-up? Why can't you have it like something happening when somebody clicks on this one? Because
so that's the exercise we're going through with TI at the moment. Provide a very low power, highly mobile solution that fits in a handheld device, and that will start an animation sequence.
So this is a prototype?
This is a prototype design that's been developed on our pilot manufacturing facilities in Eindhoven. And the idea is that this technology will be ported over to commercial LCD facilities, and that's where you see the level of performance you can see in the mock-up. But this is a working technology, fully dynamic, fully interactive, whereas e-ink is passive, bistable. We're fully interactive, just like LCD is.
How about the frame hertz, what's it called, refresh rates?
Yes, that's another unique thing about the technology is it has the broadest dynamic addressing range of any display technology. We can run it at 200 frames per second, and we can run it at sub-hertz frames per second.
Sub what?
Sub-hertz, so sub 1 frame per second to reduce power.
You can run it less than 1 frame per second?
1 frame per second with no deterioration in image quality.
There's liquid crystals in there?
No, these are entirely liquids. It's basically a water-like material in combination with a coloured oil material, and the water and the oil are what interact together to give you a very high speed but very stable optical shutter.
How might be the price compared to LCD? How long time will it take to get the price down and stuff? And in the beginning, is it much different than LCD?
Yeah, price for the technology is going to be very competitive when you compare large volumes of technology. Our target is to substantially reduce the price of e-book displays on launch, so we expect to be 25 to 30% less expensive than existing e-reader displays when we launch at the end of this year. But the basic fundamental bill of materials of the technology is very competitive against LCD.
So may I ask, compared to Pixel Chi, how does it compare?
It compares very favorably. Pixel Chi is basically LCD technology, so it still uses polarized light to create a shutter. We don't require polarizers, so we're X times brighter we're more than 2 times brighter than a conventional LCD, but if you compare our technology with a wide viewing angle LCD, then we're 3, 4, 5 times brighter, or 3, 4, 5 times more efficient than an LCD. And Pixel Chi uses standard LCDs.
So, but in terms of, you were also saying that it's in the LCD manufacturing lab, it's very important to get it in there, right? To get mass manufacturing going without having to build billion-dollar new labs and everything.
Exactly. Again, this has been a very deliberate strategy all along, is to develop a manufacturing process that is almost exact facsimile of an LCD manufacturing process. There's only one different process in the manufacturing process, and that's where we put the liquids into the display. And that's because they're different liquids. Liquid crystal's one type of material. We use oil and water-like materials, so it requires a different piece of equipment. Otherwise, it's exactly the same.
And that part of the manufacturing is, how do you plan to get that changed, or how do you plan to...
It's a single piece of equipment, and it's a very, very low-cost piece of equipment. So being able to supply that to LCD fabs, that's something that we're already involved in the discussion of.
All right. So that's cool. And what do you show here? You show some interfaces and stuff. You can.
This is just an e-book interface.
And you did measurements and all these reflectance and
so
there's no touch.
This doesn't have a touch panel on it at the moment. So the idea is to take all of the hardware that's currently in this development kit and port it into a device like this by the middle of this year.
Middle of this year, you show it there.
And that will integrate a touch panel into it as well.
Nice. Capacitive? Or what you can technology do with
we're agnostic to that. We don't care what the touch panel is. We've used both capacitive and inductive touch panels, as well as acoustic wave technologies.
Thanks.
Okay, no problem.